Hi, in this video we are going to solve nonlinear inequalities, and we're going to first do a warm-up. And what I want you to see is we have learned three strategies. We've learned that you can solve a quadratic by factoring, by completing the square, or by using the quadratic formula. So we're going to just review that briefly here, or we're going to review each one of those with the same problem. So this first problem, we would play the game. Notice we have 1 times negative 15 for negative 15 in the top position, a 2 in the bottom, and so it looks like we'd have solutions to the game of positive 5 and negative 3. So we would then rewrite it as x squared plus 5x minus 3x minus 15 equals 0. Then we have a common factor, not a greatest common factor, but a common factor of x. This is x plus 5. The negative 3, another x plus 5. And now we have a greatest common factor of x plus 5. And we factor that, we're left with x minus 3. And then we solve by setting each factor to 0. So I have x plus 5 equals 0, or x minus 3 equals 0. Subtract 5. So one solution is x is negative 5, and the other solution, it comes from adding 3 to both sides. So it's x equals 3. So my two solutions, when I solve by factoring, are x minus 5 and x plus 3. Now, or x equals 3, excuse me. Now, so this was by solve this. I'm going to put in here, this is by factoring. That was the first thing we did here. By factoring. By factoring. And then, okay, let's solve it again. This is by complete the square. Okay, so we have x squared plus 2x minus 15 equals 0. Now remember, when we complete the square, we only want to work with the x pieces. And so what we do is, our first step is to get the non-x pieces to the other side of the equal sign. So now I have x squared plus 2x equals 15. And now, remember what we want to do is figure out what goes in this slot, and then whatever goes there also goes over here. And we do that, we take 1/2 of the number in front of the x. So 1/2 of 2, that gives us 1. And then we square that. Then 1 squared, that's also 1. And so 1 is what goes in each of these positions. So now I have x squared plus 2x plus 1 equals 15 plus 1. And the whole point of doing that is now the right-hand side is a perfect square. And I know how it factors. It factors into x plus, and then we always use this number, x plus 1 squared equals 16. I take the square root of both sides, and I'm left with, we'll write this out, x, so it's getting all crunched, x plus 1 squared equals, and then we take a plus or minus square root of 16. So I have x plus 1 equals plus or minus 4. Subtract the 1 from both sides. So now we have x equals plus or minus 4 minus 1. So there's really two solutions here. One of those solutions comes from plus 4 minus 1, and the other solution comes from minus 4 minus 1. We can clean that up. 4 minus 1 is 3 minus 4 minus 1 is minus 5. And if we go back, let's see, there it is, negative 5. Notice that our answer here, negative 5 and 3, is the same answer, negative 5 and 3, that we get down here. Now, let's try it one more time, and this time we're going to use the quadratic formula. Okay, when we do this, we have x squared plus 2x minus 15 equals 0, and has to be set to 0 in order for the quadratic formula to work. And if we write the general form beneath this, we see ax squared plus bx plus c. So we know this. We know that a is 1, b is 2, and the c is minus 15. So now we put those into our quadratic formula. And if you don't remember this, it's always a good practice to try that. Let's just write it down. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now let's put in our actual values. So negative b, so I have a minus 2 plus or minus the square root. I have b squared, so that's a 2 squared, minus 4 times a, which is 1, times c, which is minus 15. All of that is over 2 times a, which is 1. So now we just clean up our arithmetic. We have minus 2 plus or minus the square root of 4. And then now I have a negative 4 times 1, that's negative 4, times negative 15, that's going to be positive 60, plus 60. We're going to divide all of that by 2. Notice that this becomes negative 2 plus or minus the square root of 64. Well, the square root of 64 we can evaluate. That is 8. Negative 2 plus or minus 8 over 2. Now you can do this a couple ways. Let's just factor for a moment. It makes life simpler. 2, that leaves me a negative 1 plus or minus 4 over a 2. But this is just x equals negative 1 plus or minus 4. And if we come back up above, there's the exact same thing. Right here, there's a negative 1 plus or minus 4. And so work that out, and we've got the same answer. So what are we going to do with this? Well, here's what we're going to do. Let's try this. Let's say the example says solve x squared plus 2x minus 15 is greater than 0. Well, that's kind of difficult, but it's already ideal because we're looking at where it's 0. So first what we do, this is called an inequality. An inequality. And we're going to solve this by, let's see what, oh, I know. First, what we do, find when quadratic is 0. Well, so then that implies, oops, I'm going to erase that. So x squared plus 2x minus 15, well, we already solved that. We've solved it 3 different ways. And we know now that the answer is x equals 3 and negative 5. So, but we're going to have to do some thinking. So I'm going to draw number 1. And you could make it perfectly to scale. I'll do it this time. Let's go. We'll put 0 here in the middle. Then I have 1, 2, 3. Then I have 1, 2, 3, 4. There's -5. Now, we're going to graph the solution. This is called a graph of the solution. Okay. Now, because we don't want the equation to equal 0 at all, it has to only be greater than 0. We know that if we put a -5 in, we get 0. So we can't have 5 in our answer, so I'm going to put a circle there. Actually, I'm going to do that. I'm going to put my solution here in a different color. How about, well, I like this magenta color. So I'm going to circle the -5 because we can't have 0, only greater than 0. Now, what we're going to do is pick a test value from each region created. Now, we look at our picture, we've created a region down. Here's a region, anything below -5. We have an entire region between -5. And finally, or I'm sorry, between -5 and 3. And then finally, our last region is anything out here above 3. So you can pick any number from each region. Let's just pick 1. And I'm going to pick something by design, meaning it's probably going to just be the most simple amount of calculating. So for example, this leftmost region, let's just try -6. So we're going to try -6. And the easiest one to use in this middle region is 0. So we're going to try 0. And in the right-hand region above 3, let's just try the next one, 4. You could try fractions and decimals, but I think that would make it more complicated. So we're going to just try something simple. All right, here we go. So now what we do is check each value. Check each value in x squared plus 2x minus 15 greater than 0. So there's 2 different ways you could approach this. You can approach it using this form here, or you can approach it using the factored form, and I'll show you both. Let's just try this. So if I put in a -6 squared plus 2 times -6 minus 15, that's going to be 36, minus 12 minus 15, that's going to be 36 minus 12 is 24. 24 minus 15 is 9, which is greater than 0, which is true. Since it's greater than 0, which is what we want, then what we would do is we shade this entire region because it's successful. Let me put a little arrow on it. Okay, so that was the -6. Let's check the 0. So now I take 0 squared plus 2 times 0 minus 15. Well, that's 0 plus 0 minus 15. This is -15. This is false. Oops. 15 is definitely not greater than 0. It's less than 0. So this is false. False, so no coloring. So we just leave that region as it is. Finally, let's check our last value. We said we were going to try 4. So if I put 4 squared plus 2 times 4 minus 15, well, that's 16. plus 8, which is 24, and I subtract 15, I get 9. I get 9. Whoa. Which is greater than 0, which is true. So we want to shade the true regions. We shade our true region. So I'm going to shade all of this out here. And put an arrow on it since this one just keeps on going. And what this shows us is that if we pick any number in those pink regions, or magenta colored regions, then that will make our inequality true. So what we've done right now is we've presented a visual picture. We call this a graph of the solution. The other way to illustrate the solution is using what we call interval notation. And what we do is for negative infinity, which is out here, positive infinity, we always do it like this. We write parenthesis, negative infinity, comma, negative 5, and then since we have a circle here, we use a parenthesis, and then we say U for union, or including, and then the other region, which is 3, comma, positive infinity. Like that. Now, and let's stop there. I have a feeling this video has gotten pretty long, and in the next video, we'll try another example. All right, thanks for watching.